Okay. Are we ready? So, everyone, congratulations. Clap for yourselves. Welcome to algebra. The beginnings of algebra, but still algebra nonetheless. So we got introduced to the variable, right? We were introduced to solve an expression when you're given a value for a variable, right? But what happens, you guys, when, shouldn't give you any examples yet, what happens when you're not given a value for x? 2 plus x minus 3x. What we did last week was find the answer when x equals 2. So you put in the answer and blah, blah, blah. You find your answer, da, 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 right? The thing is, what if we weren't given this? And we were just given this expression right here, and it said, simplify the following expression. You see, now we're no longer messing with pure answers. Now what we're doing is we're simplifying. Now we're dealing with variables in a whole new light. So in order to solve a problem like this, there's some stuff you need to know. You guys ready to know this stuff? Ready to learn this stuff? Here comes the most important question in your guys' lives. The most important problem that you will ever come across in your lives right here. What's 2 plus 2? Cool. You guys just solved the most difficult problem in the world. So, 2 plus 2 equals 4, right? Now, I'm going to ask you guys something. Why? Why does 2 plus 2 equals 4? Use your hand. You see, we are used to numbers, right? We're used to a number plus a number equaling a number. But the thing is, the reason why 2 plus 2 equals 4 is, yeah, many reasons why, but I'm not going to get into the reasons why. But except for the most important one, which is the fact that, guess what? They are like terms, right? Number and a number, right? With that same logic, tell me, what's 2x plus 2x? The same logic. What's 2 plus 2? 4. X and x, it just gets thrown there. X. It's 4x. So, this is what we're going to be dealing with. Something called combining like terms. We are combining like terms. We are spotting what are like terms. We are spotting what isn't like terms. And that's what we're doing today. So. Tell me, you guys. What's 2x plus 2? Anything? Nothing? If you're stumped, good, because guess what? Nothing could be done. Because if you notice, these are not like terms. This one has a number, this one has a number, this one has a letter, this one does not have the letter, the variable, right? So guess what? This is as simple as you can get it to. So let's dive in to learning what are considered like terms and what isn't. But this is a little intro of what we're doing today. So we have a problem like this, all right? Actually, no. Let me explain to you what are considered like terms and what isn't. So the way to determine whether a term is like or not is by two things and two things only. Is if, let me make it even more, let me make it more as if the way you're going to come across it. 2x plus x, right? You always want to see two things and two things only. Whether each term have the same variable, and if that variable is to the power of the same number. So this is what I mean. Do they both have the same variable? Does each term that you see, do they have the same letter? Yes. X and X, right? Good. Check mark number 1 complete. They have the same variable. Are those variables to the power of the same number? Yeah, both of these are to the power of 1. Remember, it's invisible, but it's there. It's to the power of 1. So guess what? You've determined this is the like term of this. Now you could add the numbers. You could add the numbers. What's in front of the variable always? It's an invisible 1, but yes, it's a 1. So once you check marked in your head, oh yeah, these are like terms. They both have the same variable. They are both to the power of 1. Now all you got to do is add regular. What's 2 plus 1? 3. What do you do next? If you've determined these are the like terms, if these terms are the same, if they're like, the rule is just throw the variable on top. Just throw it. No trick, no nothing with the variables. Guess what? There will be a trick in multiplication and division world. But we're not there yet. All we're doing is adding and subtracting right now. So 3x is my answer. That's as simple as it can get. You can't do anything else. We're simplifying here. We're not solving anything. All we're doing is simplifying. So tell me, could something be done here? No. Guess what? Guess what? These are unlike terms. Unlike. They have different variables. So guess what? Nothing could be done. Nothing. Tell me, are these like terms? Maybe. Are they the same variable? Ooh, check mark 1 done. Are those variables to the power, to the same power? Not the same power. One has a 2. One has a 1. Guess what? Unlike. You can't do anything. You can't do anything else. That's the answer. It's important to see what are like and what isn't. Why? For future math that's to come. But for right now, again, we're just practicing our like and unlike. So all these rules that I'm telling you, in order to actually add the numbers, in order to subtract the numbers, those rules are only for adding and subtracting. Only for adding and subtracting. All these rules that I'm telling you, as in combining like terms, in order to actually add or subtract, they need to have the same variable and to the same power 2. Those are what I'm talking about. And all that just has to do with the operations adding and subtracting only. All right? So then that's all we're going to do, honestly. But now, you're not just doing that today. You're not just given a whole bunch of expressions and being told, is this like, is this like, is this unlike, are these like terms, are this unlike? You're not just doing that today. What we're doing that is using that skill that you've officially acquired of spotting whether something is unlike or like and solving a longer expression like this. Yes. So this is algebra, right? You guys remember seeing this in school probably and being like, what the heck? Da, 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 da. So here's some techniques to help you. This is when combining like terms come into play. This is when simplifying comes into play. So what do? Use shapes, you guys. Use shapes to your advantage. This is what you do. I'm going to show you this technique. How about you decide to use a circle for the first term? A circle. What you're going to do now is go along this whole expression and find its like term. Put a circle on its buddy. Where is its other like term? There isn't. X to the power of 4. That's going to be in the final quiz, the final test I meant. That question that you just asked me. Yeah, so you use shapes. All you do is circle all of its like terms, x to the power of 4, right? Don't do anything just yet. All we're doing is identifying. Now you move on, and let's say you decide to use a square. By the way, I should really tell you guys this. Do you see that I'm including the symbols on my shapes? The sign to the left of each number? Do that. Always, when you're identifying it with a shape, always include the symbol to the left. Always. That's rule number 1 for today's lesson. So anyways, I use the square for the x squared, right? Where's its buddy at?
Plus 2x squared.
Oh, man. All right. Was there any other x squared? All right, so we move on. How about I use, I don't know, a triangle on the just an x. A standalone x. Where's its buddy at?
X. Or the x plus.
And guess what? The 3 is alone. It's just alone. You could give it a shape if you want. It doesn't matter. It doesn't have a buddy.
A house.
I'm going to give it a... I'm going to just leave it.
Just leave it. Ooh, red one. Fire.
It's alone. What better way? What shape than a flame shape, right? I'll give it yellow.
Oh my gosh.
Yeah. Okay, I'm wasting our time. Let's do this. So, leave any standalone term. Just leave it alone, right? Okay, guess what we do now? You combine like terms. So, let's start with our first one, the circles. What is 7x4? This is why you include the symbol to the left. Plus x to the power of 4. You see that? You're done with those ones. Move on. What is negative 13x squared? Do you see that negative? That's right there. That's why we include it in our shapes. Negatives are going to be key when with these type of problems. Trust me. What's negative 13x squared? Where's its buddy at? Right there. Plus 2x squared. Negative 11x squared. All right? So those ones are done. How about my triangles? What's plus 5x? You don't need the plus. I don't know why I threw that in there, but whatever. It doesn't hurt. What's positive 5x plus x? 6x. Positive or negative 6?
Positive.
So that positive goes there. 6x. And for those of you that probably didn't hear me, it's because there's a 1 in front of the x, right? That's why we got this 6. Those ones are done, and then next thing you know, the 3 just flops in at the end. It was never once touched. Is there anything else we can do?
Nope. Oh, yeah. Adam. No.
You can't add or subtract unless there are like terms. Are there any like terms there? Nope. If you notice, each variable has a different power, and there's no other just the number. So guess what? This is your answer. You guys are simplifying here. We're getting used to algebra. Now, keep in mind, this is going to be an important thing right here. I recommend you noting it. This thing called standard form. Who here knows what standard form is? Standard form, my friends. This was our answer, right? Let's say you were combining like terms like we were doing right here with this huge expression. And let's say our problem came out a little disorganized, such as the 3 was first, plus 6x, plus 8x4 minus 11x squared, right? This is technically the same answer, but math, you guys, likes things organized from greatest to least. That is called standard form. Standard form is arranging things from biggest to lowest, greatest to least. Right? Now, why is this considered standard form and this one not? Well, believe it or not, in math, it doesn't matter if you have 1 trillion, doesn't matter. X will always be bigger than that because we don't know what X is just yet, right? It could be 1 trillion and 1 for all we know. What's bigger than X or any other type of variable? X squared. It doesn't matter if this one had a 10x and x squared is bigger. A standalone x squared or even 2x, doesn't matter. What's bigger than that? X cubed, and so on and so forth. You're always looking at the powers. That's standard form. That's why we wrote our answer. Luckily, the answer came out like this anyways, but this right here is standard form. Do you see all the powers? So make sure your answer, always check whether it is in standard form. Got it? Cool. Like terms. Like terms. But now, one last thing before I give you the worksheet. You ready to do some more? So, this is similar but a little different, and you guys got to watch out for it. What if we're given something like this? What if we're given this? If you're given something like this, a polynomial is what they call it, plus another polynomial. Pretty much. Remember PEMDAS? We got to do what's inside the parentheses. Could we do anything that's inside the parentheses? No, because there's no like terms, right? Remember, build up the skill of spotting what's a like term and what isn't. So if you determine there's nothing to do inside each parentheses, we got to get it out of the parentheses. That way we can start combining, because I'm over here looking at this. There's this guy right there, and there's this guy. I want to get those two together. I want to combine them, but I can't because they're in two different worlds. They're in two separate parentheses. So this is what you do. If you're ever given a problem like this, and you see an addition sign in the middle, do you know what you do? You ready for this? Erase the parentheses and combine like terms. Are you guys tempted of asking why?
No.
Because something that's going to come later in math, and later I mean I think tomorrow, but previously with my parentheses, if we move on down the list of PEMDAS, parentheses, right? There's nothing to do inside parentheses. All right, which means I have to move on down. Exponents. Are there any exponents? Well, sure, there's a squared here, but I can't do x squared. I don't know what x is. So guess what? Move on down the list. Exponents are done. What's next on the list? Multiplication and division. Is there any multiplication here? Yes, there is. It's a hidden multiplication, which we'll do tomorrow. It's fine. But what you don't know is that there is a little invisible 1 out here. These invisible ones, I'm telling you, they make everyone angry. But they're helpful. If there's a little invisible ones out there, what they do is they multiply it outwards. Because if you notice, it's 1 times all of that. Right? We know that. Multiplication is seen like this in algebra. 2 times 3, right? A number next to another number inside of parentheses is multiplication. So it's the same thing here. There's a little multiplication sign. This 1 gets distributed outwards. Well, when you multiply that 1 outwards, all that happens is the same thing. It just literally comes out of the parentheses the same thing. The same way it looked. 2x plus x minus 3 plus 5x squared plus 2x minus 3. So that's why I say, hey, don't worry about it. Don't worry about the whole multiplication. Don't worry about that one thing. Just know that if you see a addition sign in the middle of 2 parentheses with terms inside, just erase the parentheses. That's the little trick for you guys. Erase the parentheses and combine like terms. Is that a cool, helpful trick? Just for curiosity, let's do this one. Now that it's out of the parentheses, I'm going to use a circle for my x squared. Where's its buddy at? Oops. Always include the symbol to the left. Always, always. I'm going to use a squared on the x. There's its buddy right there. I'm going to use a triangle for that one, triangle for that one. Okay, let's start combining like term. What's 2x squared plus 5x squared? What is positive x plus 2x? Nice, 3x. What is negative 3 minus 3? No. No. What's negative 3 minus 3? You have negative $3 in your bank account. You withdraw $3 more. Negative 6. Guess what? You guys get to use the calculator today. So that's my answer. So now one more. So, what if, you guys? What if we're given a subtraction in the middle? So this is, a subtraction in the middle. Multiplication and division, we don't have to worry about it today. That's tomorrow. Adding and subtracting, those are always a pair. They're always together. So all these rules about the x to the power of something, it's like term. It's also adding and subtraction. Right? But before, there was an addition sign in the middle of two parentheses, right? What happens when there is a subtraction sign in the middle? Yeah, so the rule here is this. Same thing as the addition one. Erase the parentheses of the first set and drop it down the way it looks. But now, you see this second set here? What you're going to do is, sure, drop it down, but each of the sign on the inside, each sign must flip. So look at this 5x right there, 5x squared. Is that a positive or negative? What you do now is drop it down as a negative. You see this positive 2x? You make it into a negative 2x. You see this negative 3? You make it into a positive. So just everything on the inside. Forget about this subtraction sign, doesn't matter. Everything on the inside you drop down, but make sure to flip the sign of each term on the inside.
So the first one stays the same.
First parenthesis stays the same. Erase the parentheses and drop it down. Second set, bring it down, just make sure to flip the sign of everything on the inside.
Okay.
The sign between parentheses
The second one.
is negative, so we will change the
Okay.
rest one.
Just on this second one, though. Yeah, just on that one. Now, guess what? We use our new skills, or our new expression, and we use our newfound skills of combining like terms, and we combine everything. Same thing. 2x squared. I'm going to use a circle for the x squares. Where's its like term at? Negative 5x squared. Move on. I'm going to use a circle for x. Where's its like term at? I'm going to use a triangle for the negative 3. I'm going to use it on the other number, which is the positive 3, right? Now, you combine like terms. What is 2x squared minus 5x squared? Is that a sneeze?
Yeah.
Bless you. What's 2x squared minus 5x squared? Say it. What is positive 1x minus 2x? Negative 1x, or just negative x, same thing, right? There's a little invisible 1 there. There was a little invisible 1 there. What's negative 3 plus 3? 0. I'm not going to do this. You could. It's considered correct, but your answers are just going to look like this. That, my friends, is the final answer. You simplified it down to its absolute simplest form. You can't do anything else.
How about when we standing form?
Oh yeah. Always make sure if it's in standard form. Is this one in standard form? Yeah. X squared is bigger than x. So it is in standard form for us. Cool. So that is what we're doing today. If we could recap, hey, this was the very first example I put up in the board. Let's solve it now. Let's solve it. What's the final, well, what should I do? Combine like terms, right? Well, here's two terms that I could easily spot. What's x? What's positive 1x minus 3x? Negative 2x. Right? The way it's ordered is the way you put it in the calculator. What's positive 1x minus 3x? It's negative 2x, right? So this is my final answer. These are not like terms, which means I'm done. But what must you always check? Whether it could be in standard form. This is in standard form. A variable is always bigger than just a number. So make sure to rearrange into standard form. Like terms. Combining like terms. Simplifying a full expression using like terms. Let's do this. Are we ready?